Well, good morning, everyone, and thank you very much for welcoming to your country. I've had a brief 2 days here already, and I've enjoyed myself a lot to start. Thanks to Sam for the warm welcome and the introduction about big data and how much of a passion that is for the engineering team at SAS as we're trying to modernize the implementation of SAS software to transition from the era where we used one single computer to work on our problem to this modern era where we want to use many computers. And we've got a lovely example here in the room. We have so many brains in this room, so many computers, right? What a shame if we only use one at a time to solve the problem. We should really teach the software to work as a team and to harness the capability of all of the computers in the cluster to solve our bigger problems and solve those problems faster. And that's the basis of the talk that I'm going to do here as soon as I learn this. This is point, down, okay? Up and down. It's a universal symbol, right? So I have four sections in the talk. The first thing I'd like to talk about is this idea of abundance, that computers are actually becoming more plentiful. The memory in the computer, the CPU processing power, and the available storage is suddenly not really such a constraint as it used to be. It used to be more of a constraint. How are we going to react to this era or this generation of abundance? The second part of my talk is more specifically about Hadoop and its impact on our software and on our industry. And the third part is specifically SAS. How does SAS and SAS software play with a nice cluster? Are we adapted for that cluster? Or are we still trying to find our way to compare the old traditional way of using SAS with a more modern infrastructure, such as a massive parallel system like Hadoop? And the last section of the talk is some results. Customers that have deployed this software in their organizations, what kind of return on investment have they made? What kind of benefit have they achieved by using our software? So here's some screen captures from Google Trends. You type in analytics, and a fairly nice growth over the last 7 years from 2007, 2014. The topic of analytics has become more interesting. Oops. Excuse me. If you type in big data to that same application, not so much about big data until maybe 2011, and suddenly big explosion of interest and topics on Google about the topic big data. How about Hadoop? So Hadoop, the interest in Hadoop in this survey of how many Google searches or what interest in those keywords are on Google, you see that everything is coming to a peak in this time, in this 2014 they find ourselves. This is a new word that's going around. Anybody familiar with Internet of Things? Yeah, one or two. The idea that everything is a sensor these days. It phones information to the cloud. The highways are censored. Our vehicles have a sensor. Our health statistics can be pooled. So much more information is available and captured in the internet that we can put our arms around all of it and process it and learn from the huge set of data. So this is the interesting era of abundance. Everything is available. We just have to ask questions of it. There's a quote from a TED speaker, George Dyson. Big data is what happened when the cost of storing information was less than the cost of choosing whether to throw it away. Right? So how about that? Just keep everything. It's a fantastic idea that if you have a question tomorrow, you can go back to the data and answer the question. You didn't have to anticipate that you would have a question in the future if you are able to save all of the information. All right, so there's these two eras. On the left, in the red, perhaps the previous generation of thinking and how we used to constrain our resources, technology was constrained. You had only so much memory to process in your program. Your hard drive had only so much capacity. You focused on the process. You tried to become more efficient at the process of doing your task. Over and over again, you improved the efficiency of the process. And the focus was on containing the cost control, save money, do it for cheaper. And this idea that it's forbidden unless the rules allow it. So put that idea to the side for a minute, and maybe that's the idea of the previous generation. What about the idea now with big data and all of the processing power of a cluster? How about if we think about things differently? It's abundant, it's plentiful, as much as we need, we can use. We're empowered by our technology. We don't work for the computer anymore, the computer works for us. Discovery-centric. Go and look around the data. Maybe there's an interesting pattern between this set of data and this set of data. Some pattern in your customer behavior and some pattern in your manufacturing supply chain. Do they interrelate? Can you make some sense of these things? You should discover. You should focus on the value. Can you find something interesting and make a useful business advantage out of that discovery? So focus on the value. Everything is permitted, unless there's a bad reason not to do that, right? We don't want to encourage the criminal activity. So think about that. Scarcity, old generation, modern generation, abundance. What does that do to how we can solve our problems with the cluster today? So on to my second topic, and I think Hadoop is a large reason to enable this idea that we can transition to an era of abundance. Let's talk a little bit about Hadoop. Hadoop is this idea. It's an open source project, very much like Linux, the operating system, commercialized by Red Hat and Novell and SUSE to bring an open source project to a commercial availability. Hadoop is an open source project, and it's commercialized by primarily the two companies Hortonworks and Cloudera. These two companies bring a commercial distribution, make it available with support contracts, etc., for our customers. But it's a simple idea that you should solve your problem using many computers, not one computer, but many computers. And you should spread your data set across all of the computers. So I'm going to say that we've got 1, 2, 3, 4, 5, 6, 7, 8. We've got 8 computers in our room here. We have got massively parallel computers because each person is a core or a socket of execution, and each of you contains some data, right? The whole data set is contained in the memory of all of our people in the room here, but everybody knows individually their age. How old are you? Now, massive parallel is this idea that suppose I want to calculate the youngest person in the room. In the old day, I would ask over there, how old are you? Okay, 23, 27, 23, 21. I would go backwards and forwards amongst all the people, and I would get the age serially, one after the other, and I would get the age of every person, and I would keep track of the youngest. That's the old-fashioned way of doing it. How about the new way of doing it? I say instead, I send the work to the computers. I say, each row in the audience, work with yourselves, find the youngest person on your row. Everybody do it at the same time. And then the youngest person on each row come to the front of the room. Maybe we have 30 or 40 people here, and we do that one more time. Find the youngest person of that collection. So this idea that we can bring everybody, all of the computers to bear on the data that was spread out is the basic idea behind Hadoop. You can do everybody work at the same time on a small piece of the problem, and then you coordinate the answer at the end. So there's really 3 good ideas in Hadoop. The gentleman with the toy, the mascot of Hadoop is an elephant. It was a stuffed animal toy of his son. But the 3 good properties of this elephant are, 1, it's very reliable, never forgets. It's very reliable data storage. It's a good hard worker. You can bring teamwork to bear. It's a social animal. The elephant understands to work as a team. The family of an elephant, the mothers and the baby elephants all stay together to protect the family. It understands that you should use a team to solve your problems instead of a single computer. So, this idea that HDFS never forgets, the computers are unreliable. So my example here, I've got a small spreadsheet. Maybe it's the list of the sales for the month. And that spreadsheet is broken up into 3 blocks because one block was too small. So the first block of the spreadsheet is stored on computer number 1 in this picture. It was stored in the minds of these people. And the second block of the file is stored on computer number 2. Maybe it's stored in the minds of these people. The third block is stored in the minds of these people. So that's not very reliable because any one failure and you've lost access to your file. But what Hadoop does is it takes redundancy. It takes a second and sometimes even a third copy of that data, and it stores it redundantly. So if the first copy was with this group of people, the second copy may be with these guys. And then the second block over there, first copy, second copy. What you find then is any one of those computers could be out of action. Power supply is broken, memory problem, whatever the problem of that computer is. But you can look amongst there and you can still find block number 1, block number 2, and block number 3. Even if a different computer had failed, it doesn't matter. So the redundancy, the idea that you spread the data, I beg your pardon, across many computers allowed it to be very reliable. Even if some fail, no problem. The entire data set is still visible. So that's the first good property of Hadoop, is that the data is spread out across the entire computer. You've already heard me talk about the idea that we can use the team to calculate on the data. We spread it out. In our example, we said your age, which is something that you naturally know, so we didn't have to spread it out. But a data set, all of the sales of our grocery business for all the branches, for all of the days of the year, could be spread across the whole computer in the thing. And then when you want to do calculations like subtotal by region or group, whatever, you send the work out to many computers. They calculate locally and they share the answer with each other. So MapReduce is this idea on Hadoop, that a way of sending your work out to the data. So there should be a little reflection here that Hadoop is a young system. It's just now entering into its teenage years, I would like to think. The first generation of Hadoop, Hadoop 1, was mostly about MapReduce as a technique to calculate across this really big set of data. In 2013, Cloudera came with Cloudera 4, and Hortonworks came with Horton Data Platform 1.2. And both of these distributions had this idea that we should actually allow for many different kinds of work to be done on that shared copy of data. So it's very valuable that we can make one copy of all the data and share it, but we should be able to use different kinds of techniques, mathematical techniques, search techniques, interactive techniques, batch techniques, to process that data. And so Hadoop has grown up. This component you hear, YARN, Y-A-R-N, is a component like a traffic cop or the coordinator, and it says this kind of work and this kind of work and this kind of work can proceed simultaneously or at the same time and share the resources or the data in the cluster. And that's a very important evolution of Hadoop, so that SAS software can exist on the cluster at the same time as other kinds of software. So simple idea, we store all the data, only one copy, right? Well, with redundancy to make the failures go away. And we allow many different software to install on that cluster and process that data according to its capabilities. So, because I'm from SAS, I'm sure that your question is, well, what about SAS? How are the SAS software on Hadoop? I want to take you through a little description of the kinds of SAS software that runs on a massively parallel cluster. Here's a slide I borrowed from Hortonworks. That's their green color. And at the bottom, all the kinds of information that an organization receives. The online transaction processing, the credit card swipes, all of the purchases that the customers make. Maybe the documents and the word processing is stored in a SharePoint site. It's available for text mining. They have an e-commerce. So they have web logs. They understand which customers and which anonymous people have visited on the website and their preferences for shopping electronically versus shopping physically at retail stores. All kinds of data generated by machines and sensors. All of that information in this generation of abundance, it should be stored. It should be stored either in the traditional enterprise data warehouse platform, an Oracle system, a Teradata system, SAP HANA, or perhaps, because it's so big and so created so rapidly, sensors, maybe you just store it directly in this new idea called Hadoop that can absorb such a big set of data and process it efficiently. So I'm not really here suggesting that the one technology replaces the other technology, yet maybe in 5 years, the Hadoop will be the only kind of enterprise data warehousing storage people have. But I think in the current generation, most organizations are trying to understand when is it appropriate to use enterprise data warehouse, relational database, and on the other hand, when is it more appropriate to use Hadoop, shared file system, and technologies like that. But the point is, you've assembled all of the data in one place. You can make connections and references between sales information and manufacturing information and weather information. Perhaps that has an influence. And you want to use many kinds of tools on it. You know, SAS has tools for the application layer, and SAS has tools for the data management layer to assemble and join data from 2 different domains to make it relate to each other. So I try to have this idea that there's a family of software that is adopted by the elephant, the mascot of Hadoop. And so that's a safari picture, the family idea that you can run more than one kind of software on the platform that stores all of your data, which Hadoop is a platform for storing data. So some of the SAS software, first off, the baby step, how can we get introduced to our cluster, is SAS access to Hadoop. If you've programmed with SAS before, you've probably used SAS access to DB2 or SAS access to Oracle, SAS access to a relational database of some flavor. SAS access to Hadoop uses the Hive, which is the Hadoop flavor of SQL language, HQL, or perhaps it uses Impala, which is the Cloudera software, also SQL on Hadoop. SAS access software is flexible, can access data in either of these sources. And then your SAS job is very much similar as it used to be. You have live name statement, point to your data, process it with SAS syntax, much as you used to. So for this first baby step, it's not really sending the work to the cluster, it's just accessing the data that lives in the cluster. The second level of SAS software as it interfaces to a cluster is this idea that we practiced with Find the Youngest Person. What if I can take the logic and wrap it up in such a way so that it runs on every server? So there's 12 servers here in my cluster, not one SAS server. That would take 100 seconds to process the job. If I have 12 servers, it should take 12 and a half seconds because each server has 1/12 of the data. So it's working on a smaller section of the problem. So you can achieve this kind of a performance by sharing the problem, not one server, but many servers. And your SAS program, your data step program for scoring accelerator or code accelerator, the SAS program is what's distributed to all of the servers in the cluster and runs on the local copy or the small set of data allocated to each of the servers in the cluster. So not just your programs, but the SAS techniques that your model building people like to use. You want to do a regression or a neural network or a decision tree to try and understand people's shopping behavior or people's their habits. Are they likely, if they buy this item, what's the next most useful item to suggest that they should also put in their shopping basket? These kinds of mathematical techniques of grouping and relating things together, it just makes sense that if you can solve I'll go back. If you can solve on many computers instead of just one, they can go very much faster. So SAS high performance analytics, Dr. Goodnight has all of the PhDs, the mathematicians at SAS, working on this idea that you should take your program, instead of run on one computer, you teach it to work with teamwork and run on many computers to solve the problem faster. High performance analytics comes with many procedures, not complete 100% of all SAS procedures yet, but a good many procedures, enough to support what a business analyst might do with a data scientist might do with enterprise miner, calculate all of these kinds of statistical models. Here's an example of why this is so powerful. So it's an animation. I want you guys to watch it very closely, okay? You ready? Here we go. So we have a problem, and we send it into the computer. Very difficult, huh? So did you see there was 2 kinds of dots, red dots and blue dots? So the red dots, let's focus on the red dots. The red dots are the data parallelism. the transfer of data from the disks to the memory of the application. In this situation, we only have 4 computers in our cluster, but quite often it can be 10, it can be 15, it can be 100. So even if it's 4, that would be 100. This could go 4 times faster when the data set was split over 4 computers. If it takes 100 seconds to read that data from beginning to end, if you can start it simultaneously at each computer at the same time, and it only has a quarter to work, you had that data parallelism. The red dots were going all simultaneously into the memory of their respective computer to begin the calculation. So parallelism in accessing the data, that's the first very important thing to try and solve a big problem. We spread the data across many computers, okay, only 4 here, but usually 10 or 100, and each computer is only responsible for a small set of the data, and it can transfer it to memory very quickly. So that was the one kind of parallelism, right? Data parallelism. But there was another kind of animation in there, the blue one, up and down. So each worker here is only working on its data. This could be the people from the south, whereas this is the people from the north and the east and the west. But sometimes you have to make a reference to your neighbor. What have you learned about your data? What is your grand total so far? What is the regression equation that you've calculated on the north? Because I'm working on the south, and maybe it influences my logic. So this mathematical parallelism, or allowing the technique to communicate with each other up and down the stack, both of these techniques are required for the high performance that SAS is able to achieve. And just focusing on the one kind, the data parallelism, is not sufficient. You have to focus on both kinds of parallelism, and that's what SAS has been working on so hard for the past couple of years, to make our analytic techniques take advantage of all of these computers at the same time. So it allows us to build software like visual analytics, which you've seen demonstrations and screenshots from. I'll show some things here. Here's an example of forecast. This was the actual data, and then here's the forecast with confidence around it. And what the computer has done, because the resources are abundant, it said, I'm going to calculate this forecast with 5 or 6 different techniques. I'm going to choose the best technique for this kind of data. And there are different mathematical procedures to do a forecast. In the past generation, we might say you should be an expert at forecasting, and you should select the right technique and ask the computer to do that technique. But in the abundant era, why not let the computer calculate all different techniques and choose the best one itself? So because there's so much extra firepower, so much extra processing power in a cluster, many computers, you see the software get smarter. It says, I'll do the work. I will calculate 5 or 6 different ways to do a forecast. I'll only show you the best one. So that's an example of the abundance in practice. Here's another one. You know, this is every variable, the capacity and the age of the machine and its quality, reliability. Which of these things are related? So probably you would expect the older the machine, the less reliable. But in practice, you have many different variables. You measure temperature and pressure and vibration and all kinds of measurements about your machines. Which one has the most impact on its reliability? You might not know. But if you can take each variable and match it to every other variable and choose the ones, in this example, red here has a high correlation. These variables are related in some way. And anything that green, not so much, not a clear relationship between those two variables. Another example of the thing you can do because of abundance. Ask the computer to calculate all these things. Many of them are not interesting. These green ones, not interesting. It doesn't have a relationship. But that's okay. Didn't waste a lot of time to calculate it. Let's focus on the ones that are interesting. So you can build a very useful user interface where a lot of the work is assumed by the computer because of the fact that it has so much more power now. It can answer many questions very quickly and only show you the interesting, your second question results from seeing the answer to the first question, and you cycle on it like that. All right, so visual statistics, Sam mentioned earlier, same user interface, more for a data scientist kind of person than average general business user. So the screenshot of the visual statistics, and it's probably better to find a demo station and have someone walk you through this, but much more statistical techniques, lift charts, and regression plots, residual plots, I beg your pardon, to express, is this a good model? Does it predict the future or the behavior accurately, or is it not yet a good model for things like that? So the direction of SAS is to use these two ideas. Very powerful backend that can calculate on a very big set of data, coupled with very useful and user-friendly interface that people can ask questions of their data very easily. Any question you have, click away, and it answers very, very quickly. So, summary of the SAS software on Hadoop. Access is just to get access to the data. The scoring accelerators take your work and move it into the cluster. The high-performance analytics takes the SAS algorithms that you may use, logistic regression or neural networks or decision trees, and again, re-implement those ideas to push the work across all of the data spread out over your cluster. And finally, the idea of visual analytics and visual statistics, a very useful user interface or a navigation tool to harness or to use the power of this cluster. And we've been working on this for a good 2, 3, 4 years now, and this is the best year from my memory that all of the ideas are coming together in a very useful way for the customers. So I just want to spend the last 4 or 5 minutes on, so what have customers done with this, right? This has up until now been my position on what SAS says about this software. Of course, we're very proud of it. We create it. We should be proud of it. But how about the customers who have used this software? What results were they able to get when they put it on their systems? So the first example I have is from Denmark, the National Board of Social Services, their hospital system. They say, let's make all of the information that the government collects about the hospitals freely available to the citizens so they can see what we do with the tax dollars. We're respecting their investment in health and social services in the country. We want to make the information available to the population. I think the useful quote here was 8 days. So the hardware arrived, installed the software, and 8 days later, they were already making web reports available to the citizens in the country of how the performance of the hospitals, how the programs for addiction and things like that were being received. This is actually a public website. You can go to this URL and learn about the health system in Denmark. I was fortunate to have breakfast with a lady from the statistics in Korea, and she says that it's actually a strong initiative in Korea too to make much of the government information open, that you can access the information, you can make your own inferences, and you can make your own calculations of, is the government being responsible with your money, with your taxes and spending. You can keep check on the government, which is actually very interesting because usually the government's keeping check on you, right? Okay, how about a large Canadian bank, right? I can't say the name. We have to respect the customers, not always allow us to reference directly their name. It's out of respect for them. 20 million customers, maybe operates business in 50 different countries, so quite a large bank, 85,000 employees, and their pain is building a good model takes too long. It takes us too long to make a good model. We don't have enough information, and we don't have enough time to try different varieties. Can SAS high-performance analytics improve this? So what they did is, the first thing, this blue line, is the data warehouse or the analytic mart that they were building. They started in May, and they had about 200 variables to work with about their customers, right? And they found a bit more data, and then they added more variables. They got up to 400 and up to 850. And by the middle of the project, 18th of June, they were already up to nearly 1,000 variables. So 5 times more data in 6 weeks. But what that allowed them to do is in the beginning, they only had very small models, baseline models, the kinds of models that they were building before. And as time went by, as they were able to use more and more data, they could make many passes, they could improve the models, they could go quickly and say, try another thing, try another thing. They could make segmented models. They could do a model once for the ladies and a different model for the gentlemen, or they could do a model for the north and a model for the south, or any other category in their data. They might build separate models for each category. So again, you can see it starts to put a demand on many more models on much bigger data set. And that's why you need a technology like the high-performance analytics to allow you to do this. And finally, they were able to build models that they didn't even think they could attempt in the short proof of concept. So in the results of this, I'll skip over this one, I'm running a little short on time. The results of this proof of concept, $6 million better performance. So already the monetary value of the project was clear, wasn't in any doubt. But it also gave them much better productivity. They thought they would do 3 models in that time, but actually they could make 10. So the fact that it was much faster allowed them to try many more things, and they ended up with more productivity from the staff that build models. So this was a very successful proof of concept at this bank, and they said, this is great, we're going to put this software into production. But you saw the dates there. It's only just recently that we've been through that with them. A telecommunications company, it's here in Asia region, wireless and wire and broadband. They had so much data that their processing started to take way too long. It started to take hours, maybe even 13, 14 hours. So you must understand, if that's your job to run that campaign or run that program, you only have one chance. You run it, and then you look at the answer, and that's your result for the day. You don't have a chance to try option A, option B, and option C. So we reconfigured their system. We brought in the high-performance analytics and Hadoop to make a conglomeration of all of the data. And we were able to do some pretty interesting things. Here's my favorite. So the project they call monthly revised location take 5 hours, now takes 5 minutes. So if you're the programmer or if you're the analyst whose job it is to work on this kind of data, 5 hours, you push the button, and that's it. You're not going to change the result of that job. You let it run, you go to lunch, you come back, and there's the answer. You won't experiment. But if it only takes 5 minutes, maybe you'll run option A and say, oh, maybe I can tweak this parameter. Maybe I can change a little bit and try again. Maybe my second attempt is better than my first attempt. And so the productivity of being creative, of trying option A, option B, option C, is definitely a value to this customer because it went from hours down to minutes. You know, some of them are much faster like that. Obviously, every now and then one is not faster. This used to be 7 seconds, now it's 18 seconds. So not guaranteed to this technique to be faster in all cases, but these are the challenges that SAS is trying to resolve. We're trying to make a problem that used to take so long that you only went for one iteration and you said that's good enough, to many iterations and many variations of it to try and improve the model or the technique that you're using. I have lots of others, but I think they've signaled the time is up. But we have lots of impressive speed up that had value to the business. So really, this is my question for you guys. Do you agree with me that this era, that the computer is now more plentiful, that we can take techniques that we didn't imagine before, we can save all of the data because we have a question tomorrow, we don't even know we have that question yet. We can't anticipate the question, but if we have the data, all of the data, we can go back and answer that question when it happens. What does this kind of abundance mean at your organization, in your company, in your part of the government? Have you started this process to adapt to these new ideas, massive parallel, Hadoop, things like that? Really the takeaway of my talk to you guys. So thank you very much. These are my contact details. I'm happy to make friends with everybody on LinkedIn and answer your emails. Thank you.